Primary. Hello students, welcome to our introductory lecture on water resources management. I would say this is our 0th lecture specifically for those who could not attend the first interaction because of scheduling conflicts. And in this video, I will give you an overview of mode of instruction, grading, the course plan, and how we plan to proceed ahead. So the title of this course is Water Resource Systems Planning and Management, and sometimes it go by the name of WRM. So, but the essence of course will remain same, that we will focus a lot on optimization and simulation based problems for water resource systems. In this video, we'll talk about how we are going to run the course, what are the grading criteria, and what topics we are going to cover. So let's start about the course, how I'm going to teach it, and what are the learning objectives. So in first few videos, I will give you a motivation that what this field of water resource systems is all about, what kind of problems are dealt in water resources, and how we visualize the systems. And then we will look into some examples that what are the typical problems, both from water quality and water quantity side in the area of water resource management. Now, one thing that would be interesting is that some of the lessons that we would learn for water resources management, the optimization toolboxes and the softwares that we will learn will also generalize to other areas of interest. And hence, this is not just restricted to water resources, but lessons can be generalized to other areas of application. But in this course, we will always have an aspect of water into our study, and you can always relate it to the disciplines of your choice. Then we will learn how to put water resource problems as optimization challenge, how to write equations, how to look for constraints, and then once you have identified the system, the optimization or the objective function and constraints, then we should definitely look forward to solve them. And we will learn various methods. We will focus a lot on linear programming that would include simplex method. We will also look into quadratic programming where the functions are not linear, but they take a special form, and we will learn about them under quadratic programming. Then we will also look into evolutionary algorithms and also nature inspired algorithms such as ant colony optimization or swarm optimization. And they are very exciting in a sense that how we have adapted those simulation techniques, learning from various aspects of nature to solve some engineering problems. We will use Python as a primary language, but you are free to use any programming language of your choice. Language is not a prerequisite, but we would expect that you show good amount of motivation to learn those programming languages, and we will do hand holding so that at the end of this course you can solve some optimization problems using programming languages where number of constraints that are involved are very large, and these things will become clear as we proceed forward. And you have to do a small project which would be based on a real world example. So you will decide a system, model the system, and try to come up with the optimal solution. And even if you cannot reach an optimal solution, you should show a promise that you can design a water resource management problem all by yourself. And again, we will help through the discussions as we go forward. So I have very few expectations. Ask as many questions as you can. I understand we are dealing with this course in online mode, so classroom fun would be missing, but we will make it as exciting as possible. And one way to do that is give me challenging questions, ask me tough questions, and I would love to address them in the best possible way. No question is stupid, no question is small. If you are confused about certain thing, keep on asking until you get a complete clarity about that. No late submissions allowed. I will give enough of time window to submit your assignments, take home exams. And if you submit late, the formula is -1% for each 1 minute of late submission. So if your internet connection is slow and you are facing some problems, make sure you submit ahead of time. So if you submit 100 minutes late, you will automatically get -100% or automatically zero. Now, another thing is that you have to submit all your submissions as .pdf files unless specified otherwise on Google Classroom. We have already initiated Google Classroom, and I will post link to Google Classroom in the description box below, and it is encouraged you join it. Similarly, we have created one WhatsApp group for better communication with students. So again, you are requested to join that WhatsApp group. And finally, you should expect fast quizzes after our online interactions. So we are supposed to dedicate 4 hours of in-class learning on this course, as it is a 4 credit course. So the way we are going to do it is that you will have at least 2 to 3 hours of pre-recorded lectures on YouTube, and I will assign which lecture to watch when. Once you watch those YouTube lectures, we will meet online using Google Classroom. And again, Google Classroom link would be posted in the YouTube description below. So now that once you join on Google Classroom, be prepared to ask questions, be prepared to answer questions from my side. And once you watch these videos, expect small, fast quizzes coming your way, which you can discuss with me, which you have to submit in a time. And if you have any questions, you can discuss with me. So these are the three expectations summed up together. This is all I expect. And finally, coming to the grading. So this is a 4 credit course, and I expect you to learn a lot out of this course without worrying about the grading. But at the end, grading is also a very important component. And primarily, I will test your sincerity and dedication to solve the problems. Assignments and homeworks would be challenging. So if you find some challenging question, give your best attempt rather than leaving it completely unattempted. So homeworks would be 20%, mid-sem exam would be 20%, which would be take home. Similarly, end-sem exam 25%, again it would be take home. And end-sem exam would have some basic programming questions as well as theoretical question. Then we will have quizzes, as I mentioned, fast quizzes or 1 day quizzes, and that would carry 15%. So all together, around 80% of your grades would be taken care of by assignments, homeworks, and take home quizzes exam. And then we will have that project component, which we will try to embed into assignments towards later half. And uh, out of this homework, major contribution would be coming from the journal club. I will discuss the details of journal clubs later on, but all of you would be assigned one research article that you have to review in team of two. That will also encourage some teamwork. And once you present, and then you will present this paper to entire class, and as if you are making students understand what this research paper has covered. You are not supposed to write the codes for these journal club papers, but try to understand what are the concepts that have been covered in that particular article. And finally, coming to the topics covered. So this is a detailed rough lecture breakdown. It will change slightly as our lectures evolve, so that when I have to estimate at what rate you are learning. But in first few lectures, we will get strong motivation, why to learn water resource systems. Then we will spend some time on a refreshing calculus and algebra, because we are dealing with optimization. We have to solve maxima, minima problems. There we would need differentiation and basic Taylor expansion. So I will introduce you to calculus and algebra, both in lower dimensions, that is 1 dimensions, as well as higher dimension. Then I will talk about mathematical modeling, what it takes to model a particular system, subsystem. And then we will go into specifics of unconstrained and constrained optimization. Unconstrained optimization is just you are given a function fx equal to x square plus 3x plus 2. And I would say find its maximum or minimum value, and it should be easier for you to do from your basic understanding of calculus, that its first differential should be equal to 0, its second differential should be less than 0 for maxima and greater than 0 for minima. So that is a typical example of unconstrained optimization. Secondly, which is more interesting and more realistic in engineering world, is constrained optimization. Now you want to maximize your gains, but you have some constraints, as if resources are limited, your costs are limited, time is limited, and so on. So how we should account for those kind of constraints? Also, you can have competing objective. You want to maximize the profit and minimize the leakages or burnout rates in certain industries. So you have to write two objective functions which are also anti or competing against each other. So we will also look into those examples, that how to formulate that problem. And then we will spend considerable amount of time on solving linear programming questions using simplex method, modified simplex method, and their extensions. And then we will move to dynamic programming. So for example, when we will deal with the staged interventions, this system is not going to be static. Output at t minus 1 is going to influence what would be the outcome at time equal to T. So that would be a problem of dynamic programming where your objective function would be a function of time. And how to solve that, that would require some special attention. And then we will spend considerable time to look into practical applications of all the concepts that we have learned to solve water resource systems programming problems using programming language and other modeling techniques. And then we will end our discussion with advanced approaches in WRS, specifically looking into the nature inspired methods for optimization. You can always write to me on bhatia.u@iitgn.ac.in. For year 2020, your TA would be Divya Bhatt, who is my PhD student and who took this course last time. And you can always reach out to me in our WhatsApp group, as I just mentioned, write email to me whenever you have any question. But idea is maximize learning so that at the end you feel satisfied that we have spent some considerable time and this was worth it. With that, I will end up this introductory lecture. And finally, touching upon the grading, that whether we are going to have absolute grading or relative grading, we will have absolute grading, and the grade slabs would be that greater than 90, greater than equal to 91%, we would have A grade, 85 to 90% A minus, 81 to 85 we will get B, and 71 to 80 it would be B minus, followed by 56 to 70 it would be C, 50 to 58 it would be D, and less than 50% you are going for an F grade. Now, to get F grade, you have to work very hard. Don't do anything for these assignments. Don't submit your projects on time and don't attend classes. And that would be an easy F grade. On the other hand, be sincere, submit all your assignments on time, give 100% to each and every problem that is being discussed, take every lecture seriously, and then nobody can avoid giving you an A grade. And between them, the grading would be objective, rational, and would uh, be balanced with the difficulty that you are going to have in each assignment. So that's it for first lecture. Thank you, and I look forward to see you in the class.